Okay, so today we're going to start some complex applications of this. We done some of the simple ones, so now we're going to find some more complicated ones. So we'll try that again. So it's something like this, where we have a round piece settled into a, not necessarily a V block, but you see the point there. We're going to go with, I'm going to say that this is 64 degrees. And let's call this 28 degrees. I'm going to call this X, so I want to know that height. If this is 0.800 inches, and this is, oh, who cares? It doesn't really matter, does it? No, it doesn't. I just got to tell you that this is diameter of 1 inch. Where are we going to go from there? Tell me what you know here. Well, we know we got a dot there.
Radius is 0.5.
We know that's 0.5. Why did I draw it like that?
That's tangent, right angle.
Okay. So we know both of those are going to be right angles. If I cut this across here, do I know anything about those triangles? See, yes. Yes, I do.
Yes, you.
I do. I know a lot about it. One thing I do know is I know this and this are the same length. Even though the angles aren't the same, I know those are the same length. So we got two of those two triangles are equivalent. I'm going to draw one of them out right here. This is my 0.5 inch radius. This angle here I can find. How can I find it? Well, I'm going to draw this in. I'm going to do this. I'm going to complete these right angles here. If that's 64, this is 26, correct? Because if that's a right angle, those have to add up to 180. 64 and 26 make 90, plus 90 is 180. This would be 26. This would be 28 here, right? Same as this one. If that's 28, this is 62. So what I have here is 88 degrees. So that's 88 degrees there. If that's 88 degrees, this gets cut in half as always, so this is 44 degrees. Half of the 88. So now that I know that's 44, I can find this side and this side, and we can go from there. In fact, all I really need is this side here. So let's find that hypotenuse. So from the 44, this would be what side? Opposite. So I have opposite hypotenuse makes sine. So sine of theta equals opposite of the hypotenuse. I know the angle is 44 degrees. The opposite is 0.5. I am looking for the hypotenuse. I put this over 1, so I have 0.5 divided by sine of 44. Giving me 0.7198. So this is 0.7198 inches.
No,
What's that tell me? What? Go ahead.
is everything we deal with, can everything be dissected by right angles?
Pretty much, yes. Almost all of it. In a couple of days, next week, we're going to look at what happens if there are no right angles. We're going to look at Jared triangles. What are they called? Yeah, they're just not right. Yeah. So anyway, what we have here now, this distance is the 0.7197. I'm going to create this triangle right here. This is 0.7197, or 98, sorry. This angle down here is going to be this 44 degrees from here plus the 28. Do you see how I got that?
Say again?
This angle down here is going to be,
Angle down here.
well, here, let me draw it up a little bit bigger for you. This was 44 degrees here, right? And this was 28 here. So what I'm looking at now is if I draw the triangle like this angle is 44 plus 28, which is going to make this 72 degrees here. That's just a 44 plus 28. So what I really want is this height here, which is the opposite side, based on a 72 degree angle. Guess what? We got opposite hypotenuse again. That is sine. What's that? 2224? Oh, yeah. So we got sine of 72 again. Equals opposite over 0.7198. And put it over 1. So you got sine of 72 times 0.7918. I got 0.6845. So that's 0.6845 or 0.685. 46, is it? Nope, 45. So that's 454.
Okay.
I kept it in my calculator instead of rounding it off and writing it down and punching it back in. So I can see where after any little bit of round off that would have been 46. You're right. Right, so 6845 is this height here. From here to here. Add that to the 0.80. That makes this total height from here to here of 1.4845 plus another radius of 0.5. That's 1.9845 from here all the way down. That's what we're looking for. So what we're looking for in these problems here today, and I'm not going to be able to talk for very long, so I'm sorry, but what we're looking at in these problems here today, we're not just finding a single right triangle. What we saw here is we had to create a right triangle, which the first one is pretty standard because we're dealing with just the radius to a tangent and then to the center of the V. But then once we found we need that one right triangle to find a dimension. In this case, it was this dimension. Once we found that dimension, then we created a different right triangle to use that dimension in to find what we're actually looking for. This is not very uncommon. This is really common that you have to do this in machining problems. So in the packet that I gave you guys yesterday, I want you guys to work together in groups on this, and I'll come around and help you. The packet I gave you a couple days ago. Probably gave it to you on Tuesday. The front page should say Unit 58, I believe, or let me see. Unit 55 on the front. Yep. On page 368 through 370. Problems. Yep. Problems 1 through, actually 371, 1 through 23. So I'll work on those together. 23. So that goes to 371. I'll come around and help you in small groups. I can probably whisper enough. I just can't talk this loud much longer. I'm going to lose my voice totally.